Welcome back to this lesson. So on this slide, we'll be looking at memory enables learning and continuity. So the course is still Agentic AI Product Management. So if this is your first time of coming to this channel, please kindly like and subscribe. God bless you. Encourage your girl. Thank you. So we have memory enables learning and continuity. So we have 4 types of memory, as we have said. We have the episodic memory, which help the agent to remember what happened 5 minutes ago or one day ago. It keep agentic conversation that is maybe 5 minutes old, and so on and so forth. We have the procedural memory, which is where it helps the agent to learn the right way to perform a particular task or business over time. So procedural memory can be an historical data in the warehouse or in a database. Then we have the semantic memory, which is just like a vector database and RAG that we have discussed. So it helps the agent to retrieve information from vector database to augment the current information it has. And then the other memory we have, which is not listed here, is the working memory. So another type of the memory is working memory. Okay, so we have working memory. So working memory, it keeps the current information, okay, current information from the agent. That is what's in the working memory. It's just like catch in software engineering, where present information can be kept, and if you want to access it maybe 1 minute later, you can retrieve the information from the cache. For example, if you log into a website and then you leave the website on for like for like 5 minutes, instead of logging you out, the website keep your information, and then you don't need to log in again. You just access your page and then do whatever you want to do. Okay, but if you come back the second day, the information might have gone, and then you need to log in the second time. So that is what working memory is. It keep the current information or of the agent, or current or conversation of the agent now. Then after some time, maybe after 5 minutes, 1 minute, it then discard it and send it to episodic memory. So these are the four types of memory engineering in agentic system design. Then we have multi-agent collaboration for specialized work. So how can you use a multi-agent? How can you design for multi-agent system? So the enterprise problem now is depend on multi-agent orchestration. So no one agent can perform a task. If you don't want hallucination, if you don't want failure, you have to implement multi-agent system. And then that is why we said you should think process instead of task. Okay, visualize business problem as process, then break down the process into smaller tasks, and then chain the tasks together. Then the planner agent then handles the task one after the other by breaking it down into actions, and then actions are sent to specialized agents. So in multi-agent design, you have workflows. You have multiple workflows that are divided into subtasks, and then agents are assigned to those tasks. So an example is researcher agent for researching data in the database, looking into different database to retrieve information. We have the writer agent, who draft the content of whatever the researcher agent derive. And then we have the critic agent, which is the one that will critique what the writer has written, and then remove unnecessary information, and then retrieve or maintain or retain good information, okay, for quality and compliance. And then it's also passed through guardrail and governance and company policy before it's send it out. And then we have efficiency agent. These are specialized small model, okay, that work together to form one giant. Okay, they do it all. Specialized small model work together than one giant do it all model. So you, instead of designing a giant do it all model, you have So you break task it down, you break the task into subtasks, and then you assign the subtasks into specialized agent that can do it very well, instead of just designing one gigantic agent that will do it, that will combine everything together and may not give the best output. So multi-agent system is always effective in enterprise than just one agent, but it has to be designed carefully as well with governance. Then we have CADABA orchestrator logic. So I discussed a lot about orchestration architecture of multi-agent system in my book, Multi-Agent Orchestration Design, multi-agent orchestration design for enterprise scale system. And then the highlight is on the YouTube here, where I break each chapter, where I summarize each chapter into slide. And I taught the course here, which is on YouTube here. You can look for it and also watch it if you are an agentic AI engineer here. So CADABA orchestrator logic. So we have task routing. This is directing a query to the most capable agent. Okay. So routing is directing a query to the most capable agent, and the agent in turn call a tool to implement the task. Then we have conflict resolution. This is what happens when two agents disagree. So when two agents can disagree on task, okay, so we have a kind of a democratic orchestration where agent just subscribe to task, and then the task, anyone that win just take over the task and do it. So in democratic orchestration design, agent can fight for task, and they can argue over a task through code. These things are algorithm can also oppose each other. So when algorithm opposes each other over a task, then you have a conflict between two agents. So what happens when two agents disagree? So instead of allowing agents to communicate with each other, it is better to have an orchestrator engine that will coordinate the activity of the agent. So instead of agent A communicating directly with agent B, orchestrators send information to agent A, then agent A perform the task and send the information, answer back to orchestrator, then orchestrator in turn assign the task or the continuation to agent B. So orchestration layer allow or resolve conflicts between two agents. It doesn't allow agents to communicate with each other. It acts as the central layer of agentic system communication. So all agents communicate with orchestrator. Then orchestrator look at the action, look at the task, and give it to the best agent. So this resolve a conflict between agents. Then we have state management. So keeping track of the status of a multi-agent multi-day business process. So orchestrator enable agent to manage states. State is memory. So memory of the agent, the database, the information, the brain, and how they coordinate is called the state. So orchestrator also enable agent to manage states. Every information of each agent is written to the database of the agent, and the orchestrator also routes, enable agent to route, their information to their own database, instead of mixing information or writing the information of agent B into the database of agent A. And then we have a bounded context. So bounded autonomy, progressive responsibility. So we said that agentic systems are autonomous systems because they have the capability of reasoning and acting on their own without any intervention, with planning and looping also in place, with neurosymbolic architecture and the recursive learning and reinforcement learning that enable them to retrain themselves and perform better. So the fact that their autonomy does not mean they should not be bounded. Okay, so even in enterprise system, you have domain are bounded because every domain data is contained and registered in that domain. For example, human HR data is registered in HR, while finance data is registered in finance. And if you want to design an application for finance, you will not allow the application to have access to human resources database. So that is bounded context. So agent must also be bounded. Agents must have limits. Agent must have what they can never access. So if you are building an agentic system for a particular domain, let that agent be bounded to the data and information of that domain. Let it not access other domain. So even though there can be later domain to domain communication, even as system is going, there can be enterprise communication between agents, where agent in energy enterprise, for instance, will be communicating with agent in banking sector. So those are still advanced technology, but right now autonomy of agent must also be bounded. So how do you design for bounded autonomy? The first thing is implementing what is known as sandbox mode. Okay, so sandboxing is limiting what the agent can do, what it can interact with. So agent acts, but nothing happened in the real world. Okay, so the agent is sandbox, or it is bounded into the domain. It cannot interact with other domain. It is built and contained in the particular domain, not other domain. Then we have policy boundaries. So for bounded autonomy, the best way is also governance and policy. So you can use the particular domain policy to bound the agent within that boundary. So policy will say you can spend up to $500 without asking. So any amount that is more than 500, the agent is not allowed to take action. It should automatically send it to human in the loop to approve. Okay, and then we have human oversight. This is high risk action, like deleting a user or sacking an employee always require a human click. So agent must not never be allowed to sack an employee. For example, if you have an agentic system in HR, you must never allow the agent to sack an employee. Okay, you must never allow to the agent, or okay, you can use the agent to pay salary. Agent can pay salary, yeah, very good, but like sacking an employee, you can't allow an agent to sack an employee unless it is it is a high risk situation. Deleting a user database or automatically logging out someone from a system. So risky action must never be or risky action must be taken out of agentic system action. There must be action that they can never perform, like high risk action, or action that involves human being, sacking human being, deleting a user, or just accessing finance database anyhow. So always must those one must always require human approval. Then challenges in productionizing agents. So just like we have challenges in software engineering and design, there are challenges in productionizing agents. So I've built like up to, let me say I've built up to 30 agents now. Yeah. So and there are still challenges of managing this multi-agent system. Okay. And one of the challenges is security. Of course, they're solving the problem of security now by using governance and policy, but there are still other challenges in form of data drift, in form of safety hazard, where you have swarms of agents, and in form of cost runway, cost of token, LLM usage, and all these things. Even these big companies, Amazon, Facebook, and Microsoft, that are sacking people, they still have challenges even after they deploy the agent and they are using it. Okay, so most of the challenges are infinite loops. So agent can continue to look for hours, look for days, finding the best action, the best way to perform the task until we can find one. So I noticed recently that ChatGPT 5.6, the new model, normally loops. It will continue to think and research, gather all information from website until it is satisfied with the information that it has. So infinite loops, the agent keeps trying the same failing tool call. Okay, so if you don't design for this, it will just keep on trying even when the tool is failing. If you don't put guardrail that when this tool fails 3 times, then withdraw from it, it will just continue to loop. Then context drift. The agent forget the original goal after too many steps. So when it's trying maybe 10 times, it forgets what it's even doing and just continue to try. So it can make the agent to operate outside context, outside the given instruction when the loop is too much. Safety hazard, unintended tool calls that break production system. So agents, you must prevent against this. Agent must not make call tools anyhow. Even though tools can access the website, tools can call the database or access databases, tools can do many things. There are some certain tools that agent must not be allowed to call. You can hear the news of GPT breaking into LangChain database and accessing information by breaking tool. So it has called a particular tool that is not allowed to call, and the tool has access to the information system, or the tool bypasses all the guardrails of LangChain and access their database. So cost runways, an agent performing 100 to 1000 calls for a simple query. So this to mitigate against this, we have discussed that you should use SLM, use simple agent for simple task, complex agent for complex task. Okay, so cost runways do not allow do not allow agents to call complex model just because of simple task and then continue looping over the token, continue consuming token on a task that it cannot perform. So these are still problems in productionizing agents. Of course, there are some of them that you can use now. Cost runway, for cost runway, use simple model for simple task, complex model for complex task. But you can still lose you can still burn token when you design infinite loops. For infinite loops, to solve the problem, you can set a guardrail that when the agent try a tool call, when a tool fail like twice, the agent should stop and should not call the tool again. And then context drift, so the agent forget when there is infinite loop, it can forget what it's currently doing. That's why you should put guardrail in loop. And safety hazard, to never allow agent. In fact, you should even never design a tool that agent must not call, because if a tool is risky and a tool has capability of accessing and breaking into a system, why designing it in the first place? Because if you design it and put it in the architecture, the agent may just, this agent, they reinforce, they learn recursively. So when it learns, it can just automatically improve itself and access the tool and use it. Okay. A roadmap to the autonomous enterprise. So what is in the future? We know that there's going to be autonomous enterprise. Yeah, that is the future. So where you have a hierarchical agent society, you have swarms of agents performing tasks like all employees. You have CEO agent, CTO agent, CFO agent. You have a manager agent in every department. Then you have the worker agent in all departments, and then you have the support agent, and then agent manage the whole business operation. So you may not even have maybe what you have is the CEO, the entrepreneur or the business manager or the business owner running the business with agents taking action on their own. Okay, so that is autonomous enterprise. So what is the process of designing autonomous enterprise? So autonomous enterprise is still in its early stage. Even though people have started using it, we have Mark Zuckerberg that developed a second brain to manage his business, to act on his behalf, and so on and so forth. So stage one of designing autonomous enterprise: individual agentic feature in existing software. Okay, so there must be individual agent in existing software or software application. We have an agent. Stage two, autonomous workflow for narrow department. So all departments will have their own autonomous workflow, from departmental manager to departmental workers. They have their own agent. Even support, we have their own agent. Security teams, every individuals have their own agent. Then we have stage three of this design: multi-agent orchestration across whole supply chain. For example, the whole supply chain, for instance, supplier register, supplier admin, supply chain admin, contracts, the contract admin, the PO officer, and the finance officer, and the procurement officer, and all of them, you know, being built as a multi-agent workflow. I built a supply chain agent and a procure IQ agent recently, where I combine all the activity of a procurement officer into an agent, 7 agents deployed on cognitive architecture. Then I built a supply chain recently. Okay, what the supply chain does is all every activity of a supply chain manager or of a supply chain department assigned to agent, then the agent just acts as the department, and the orchestrator acts as the manager that manages the agent. So that is the future of work: multi-agent orchestration across the whole supply chain. Then every supply chain task is awarded to an agent, is assigned to an agent, and then you have community of agent instead of community of worker. You still have the employee that will own this agent. Okay, stage 4, this is governed autonomous decision making at the board level. So stage 4 is taking autonomy to the board level, where you have CEO agent. Okay, CEO have CEO agent, CFO have CFO agent, CTO have CTO agent. Okay, and CSO have CSO agent, IT manager have IT manager agent, general manager have general manager agent, departmental manager have uh, departmental manager agent, and then you just have hierarchical agent society, where you have all these classes of agents and their sub agents under them. So this is an autonomous enterprise. So even though many companies have not started adopting it, but when this multi-agent system fully expand, this is what we are building towards. This is what enterprise is going towards. Okay. So designing UX for AI uncertainty. So the next thing we have here is how to design UX for AI uncertainty. So this is an LLM, and they are probabilistic model. They are built on stochastic probability and so on and so forth. So design UX for AI uncertainty. The first thing you should include in UX design is transparency. Okay, make the user interface usable, make it understandable for users. Showing the agent work in progress to the user. Agent work in progress must be shown to the user. The agent analysis of the work that the agent has done must be shown to the user. The risk threshold, where you can adjust the risk threshold on the UI, must also be shown to the user. So you have just the platform containing all the agentic information. So instead of viewing from the backend, they can just view all the activity of the agent, whether where human in the loop is required, where everything is required on the UI. So that is transparency. Then editable output, always letting the human refine the final result. Let human refine every final result of an agentic AI system. Okay. Actions that are risky. You can give a certain level of autonomy. You can give 100% for tasks that are not risky, and then maybe like 70 or 60% to risky tasks, so that human in the loop is still required to review the action before it is approved. Then confidence visualization. So confidence visualization should also be included in the UI design, where you can see graphical analysis of how confident the agent is. So if it's 70% sure about the recommendation, it will say it's 70% sure. If it's 100% sure, it will say, so that you can judge and take strategic decision before the action is approved. And then failure design. So failure also should be where user can see where the agent has failed, should also be included in the user interface. So this will allow users to know what the agent is doing well and what is not doing well. But if a task fails silently and it is not recorded, a user will not know what is going on, and they would think the agent are working well. So failure failure design should be included in the UX. So graceful way for agent to say, I don't know. Okay, if they don't know a task, they should say, I don't know, instead of trying and trying and trying and burning tokens. So UX component for enterprise agents. So what are the UX component for an enterprise agent? So the components are what we have here. So for an enterprise agent, you should have listening log. So you're a platform in the UX where you will see how the agent is listening and performing a task should be included. There should be a drop down showing which tool were called and how they were used in the UX. Then we have evidence bus. So this is where citation and link to source document are recorded. So you will see what API the LLM has called, what tool it has accessed, what information has it gotten from the web. It should be included in the UI as well. Then we have approval button. So button for approval or risk analysis, risk threshold adjustment should be included. Button where human in the loop can click for approval should also be included. So a physical checkpoint for high impact action for human should be included. Then escalation. So a US component should be included for enterprise agent in the UI where agent can escalate risky actions. So a way to quickly call a human expert into a chat. So this should also be included. So this will allow the agent to be trustworthy and transparent. So escalation hub where the agent escalate risky action to human, approval button where human can click and approve or reject, then evidence bus keeping all information that the agents have used, the API and the MCP tools it has used and the function it has called, and how it is using the information in the database, and reasoning log showing the process of reasoning and how the agent is breaking tasks, planning and breaking tasks into subtasks. And then lastly here we have AI governance. AI governance is very, very important. Okay, so you should not develop what you cannot govern, and if the enterprise is not yet mature to implement governance and policy for agent, you should not design agent yet, because if you design an agentic system that you cannot govern, you are exposing your company to fraud, you are exposing your company to hackers. Okay, so without guardrail, agents are not safe at all. So AI governance, balancing speed and risk. The first thing here is security. So protect API from prompt injection and attack. So make sure you implement guardrail. Okay, company policies must be used to protect APIs from prompt injection and external attack, even when agents have access to them. We have privacy. This is ensuring customer data isn't used to train public models. So privacy, collect data that you need, and do not collect the one you don't need. Give agent access to data that they need. Do not give them access to what you don't need. Redact PII information from training data and encrypt data at rest and in transit. Bias, regular auditing to ensure agent treat all users fairly. So agents must be audited. Okay, so their metrics, everything, activity, everything they do must be audited to ensure that they treat users fairly, because agents can be very strict sometimes. If you have been using Cloud Sonnet lately, you see how Cloud Sonnet argue bitterly with users. So those are not an empathetic way of communication. So agents should be audited to make sure they treat users fairly and interact with users politely. Accountability, know exactly which human owns each agent output. So even though we said design autonomous enterprise, it doesn't mean that you should wipe out all the employees. So there are employees that you still keep. Employees are still good. Agent is a probabilistic operation. It can succeed and it can fail. So there should be an employee that will still manage it and that will own the agent. So researcher agent, there should be a research analyst that will own the agent. If you have a manager agent, there should still be a manager that will be responsible for every action the agents take. Okay, so what we are using agent for is just to to optimize processes, to implement tasks that take months, week to achieve, implement it in within a minute, or within certain hours, and it is done, thereby generating value, reducing human effort and human time in performing a task, and generating what the business should do, and generate income, times 5 of the income within a day. Well, if the tax is taking like 3 months, how will it generate that kind of profit? So that is what agents are for. They are not meant to replace human being. They are meant to make the business better and make more profit and reduce human labor. Okay, so know exactly which human owns each agent is very, very important. All right, so we will stop here for now, and then we'll go and come back. So when we come back, we'll come and look at the constitutional layer of CADABA, which is my framework for building multi-agent system. So see you guys. Thanks for listening. If this is your first time, please like and subscribe to encourage your girl. Thank you.